Good morning to all. Welcome to my channel Fidjan. Today we discuss electric charge and electric field lesson, 12th standard first lesson. In this one we discuss electric field due to continuous charge distribution. Continuous charge distribution. See, first we discuss electric field. See, electric field. Electric field means, for example, see, this is the plus Q charge. Electric field means a region around a charged particle within which a force is exerted on another charged particle. For example, here we can take this point at r distance from that point, P point. What is the electric field? For finding electric field, here what we can do now, here we can place one test charge Q naught. Q naught is the test charge which is very small and it does not form any electric field. It is always positive. Here we can place what happened now, this positive charge exerts some force on this one. So due to that, that force is here F equal to K Q Q naught by R square. Means force due to plus Q exerted on test charge by test charge, we get the electric field. See here, electric field equal to force exerted on test charge by test charge. This is the electric field. See, force exerted on test charge by test charge. Force exerted on test charge is K Q Q naught by R square and test charge is Q naught. See, this Q naught cancel. What we get here? K Q by R square means electric field equal to K Q by R square. This is the electric field due to plus Q charge at point P or distance from the charge. What is the electric field? E K Q by R square. K Q by R square. This is the electric field due to this plus Q charge. Means here we can place plus test charge. Here we can place. Here we can place. What happened now? It exerts some force on test charge. So means around this charge, some region, its influence will be exerted on another charge. That influence around the charged particle is called as electric field. Means a region around a charged particle within which a force is exerted on the another charged particle, that region we call it as electric field. Electric field formula is E equal to K Q by R square. It is the formula for electric field. Magnitude of electric field is this one, K Q by R square. Intensity of electric field, we call it as intensity of electric field. See, now we discuss electric field due to continuous charge. See, for example, we can take continuous charge means like this. We can take, this is the continuous charged particle. See, like a rod, iron rod. See, it has plus charge is there, plus continuous charge. See, here at point P, a distance from the this continuous charged particle, what is the electric field? This electric field, what we find out that one. For that, what we can do now, first see here, it is the means large object, means big objects, means here Coulomb's law is not valid. So Coulomb's law is valid for only point charges. That's why we can take now first, this length is L. See, this long means extended object. This extended object we can cut small parts. This part we can cut. This length is means this charge. What is the charge on this part now? dq. This is elemental part, elemental charge dq. What is the length now? This one dx. From here, this point, what is the distance to the point P now? X distance. This case, what is the electric field now? Here we electric field is dE electric field. What is that dE electric field now? Q means dq by distance is x. So means x square. What is the electric field due to dq charge now? dE equal to K dq by R square. This is the electric field due to this small elemental part or elemental charge particle. So dq, what is the electric field? De. So we can cut here this part, this part means small part we can cut, all the parts we can find the electric field. So that is k dq by r square, k dq by r square. See here, in this case, first we can write linear charge density. Linear charge density means this lambda we can represent. Linear charge density, lambda equal to charge per unit length. Charge per unit length. Now see here, lambda, linear charge density. Charge is what here? dq. Yeah. Length is here dx, means dq by dx. This is the linear charge density for this elemental charge. See, dq equal to what we can write? Lambda dx, means wherever dq is there we can use lambda dx. Here is there na k lambda, we can write here k lambda dx by, means here or means here x na, so x square we can write. See, x square here na, distance is what? X, so x square, here x square. So what is the de equal to k lambda dx by x square. It is the electric field due to dq charge. This type of how many is there? Infinite is there. Why? Because this is extended object. So extended object is Coulomb's law is not valid. That's why we can cut small parts. All parts we can find out electric field and all will be added. So added means infinite terms we can add, infinite electric fields added na, we can take integration. So integral dE equal to integral k lambda dx by x square. So integral dE means E. So that means E net, that one electric field, net electric field equal to what now? Integral k is constant, lambda is constant, dx by x square. Here see, where starting is length a, what this length is, external object length is L, so this length a, so a to a plus L total. So for this part na a length, this part na a plus L length. From this minimum in between, so many small elemental regions is there, means elemental charge particles is there, dq's. So that all we can add now, that's why we can take here a to a plus L. See, a to a plus L limit. Understood at this point? See, once this is the extended object. For that, what we can take na, small parts we can cut. For that small part, what is the electric field here? We can find out. So what the distance here? X distance. This charge is dq, length is dx. So we can use what is the electric field? De equal to k dq by x square. So de equal to k dq by x square. See here, lambda means here linear charge density. Linear charge density means charge per unit length. Total charge na q, length is L, so we can take q by L. Here, what is the charge here? Elemental charge only, means dq. Length is dx, dq by dx. In this case, dq equal to what we can write? Lambda dx. Here, instead of dq, we can write k lambda dx by x square. See, dE equal to what? This due to this dq, what is the electric field at point P na? dE equal to k lambda dx by x square. Again this dq, this dq, this dq, this dq, all dq's add dq's, electric fields is there, dE1, dE2, dE3, like this is there. All we can take integration. Integral dE equal to integral k lambda dx by x square. See here, dE means E, integral k lambda dx by x square, where to where? A to a plus L. A starting point, this part, this elemental charge ending. So means totally cut small part na, totally how much? A to a plus L. That's why we can take interval is a to a plus L. See here, E net equal to what we can write na, k lambda integral 1 by x square dx na, what na formula? Integral x power minus 2 we can write. So means dx, what we can write na here? See, minus 2 x power, sorry, x power minus 2 plus 1 by minus 2 plus 1, this one. So means what we can write? X power minus 1 by minus 1, means minus 1 by x. What is the integral of 1 by x square dx value na? 1 by x, minus 1 by x. So that only we write here, integral minus 1 by x, interval is a to a plus L. See here again, integral 1 by x square dx na, x square denominator is there, changes to numerator x power minus 2. So x power minus 2 means integral x power n dx na, x power n plus 1 by n plus 1. So n means here minus 2 plus 1 by minus 2 plus 1. Minus 2 plus 1 means minus 1 by minus 2 plus 1 minus 1 means minus 1 by x. This is the integral 1 by x square dx value is minus 1 by x. That only I write here minus 1 by x. What is the interval a to a plus l? So I write here, see, E net equal to, first we can write upper limit k lambda minus 1 by a plus l minus of minus upper limit minus lower limit na, minus of minus, see, minus of 1 by a. So what we can write now here, see, E net equal to k lambda minus 1 by a plus l plus 1 by a plus 1 by a. See here LCM na, here this one minus a, here a plus l. So means here k lambda into minus a plus a plus l by a into a plus l. See minus a cancel. What we get now finally, E net, I write here E net equal to what we have, L into k lambda means k lambda L by a into a plus L. This is the electric field due to means continuous charged particle. So means this is the, so means L length iron rod, for example length of object, this object, due to this object what is the net electric field na, k lambda by a into a plus L. So this is the process to find the electric field due to this charged particle, continuously charged particle. So understood this one. See again once, what we can do now, this length of object Coulomb's law is not valid, so we can use, it will cut into small part, each part we find out dE electric field. So that electric fields all added, we can take integration. So integral E net equal to na, we can write here E net means integral dE equal to integral k dq by x square, actually electric field dq means lambda dx. So lambda dx we can write here by x square. See k lambda dx by x square, integration we can take k lambda dx by x square, k lambda is constant, outside we can write dx by x square, integral is, interval is a to a plus l. Why? Because a plus l total rod is connect means completed, so that's why a to a plus l. So k lambda minus 1 by x, integral 1 by x square, integration na minus 1 by x, so minus 1 by x, a to a plus l we can write interval. So first upper limit, later lower limit, so minus of minus plus, minus 1 by a plus l 1 by a. See cross multiplication na, so we can write minus a into a plus l, minus a plus a cancel, l only there, a into a plus l, k lambda l by a into a plus l, E net equal to k lambda l by a into a plus l. This is the net electric field due to continuous charged particle or continuous charged distribution. So this is the electric field due to this one. So write it. Next we discuss, so semicircular rod. Semicircular is length of rod, linear rod. So semicircular rod we can take. See for example, see next na semicircular rod. What is the electric field due to semicircular rod? See we can take here, in this semicircular rod charge is distributed continuously. Here positive charge distributed continuously. See here we can take center point. This is the center point. Here see, this is the radius. See we can take small elemental region. Why not? Extended object Coulomb's law is not valid. So we can take elemental parts. See this part. This is dq, charge is dq, length is dl. This angle is actually from here theta angle. This is d theta. So it is radius is r. See for that here due to this part, what is the electric field? Here see positive charge na, this side is there dE, here theta, here also theta. See it has two components, one is along this one. See dE na, which side theta is there, that is cos dE cos theta. This one dE sin theta, dE sin theta. See dE cos theta, dE sin theta. See one component is dE cos theta, another one is dE sin theta. See electric field is due to this dq, this is the electric field dE. Here theta is there, from here we can take small elemental part, that is dq, and length is dl, radius is r. What is the angle now here? D theta. From this, what is the angle? Theta. So this theta na here also divide vertically opposite angles. See this DE has two components, one is horizontal component, vertical component. Which side theta is there, that is cos, opposite is automatically sin. So DE cos theta, DE sin theta. We have two components, two electric field components is there, DE cos theta, DE sin theta. Now see same symmetrical part here, see symmetrical. So this symmetrical is this one. See here, this is dq and length is dl. Yes, theta is here theta, from here it is theta. See this angle theta na, this due to this charge dq charge, electric field is this one dE, it makes some angle theta. So when this theta means this also theta, by now vertically opposite. So it has two components, one is this direction dE cos theta, which side theta is there, that is cos, opposite is sin. So dE sin theta, it is dE cos theta, dE sin theta. Right here dE cos theta, dE cos theta will get cancelled, will get cancelled due to mirror element. Mirror element means symmetrical. This is symmetrical to this one. This part na, this one. This part na, this one. This part, this part. Means here symmetrically is there. So means dE cos theta, dE cos theta cancel. We have only dE sin theta. This is the negative side, it is positive side. So that's why both are in opposite direction. Na. So this is this cancel. What we have only dE sin theta is there. So this all dE sin theta we can add. What we get? A net electric field we are getting. So where theta to 0 to 180. What is the interval now here? See here 0, this part is 0 to some angle like this. What happened here? Totally means 0 to 180 degrees. Interval is 0 to 180. See total electric field na, see net electric field we can write E net equal to integral dE sin theta, dE sin theta. What is the interval? 0 to 180 degrees, 0 to 180 degrees. So interval is 0 to 180, dE sin theta. Here we can write E net equal to, we can write dE. What is the electric field due to this dq? So now here write here dE equal to what now? K dq by, what is the distance between them here? R. See dq by r square, dq by r square. One more, here we can write k dq by r square sin theta, and dq means before that linear charge density. Linear charge density means linear charge density lambda equal to charge per unit length. So linear charge density equal to charge is dq, length is dl. So dq equal to what? We can write lambda dl. See here, for example, here we can take, this is the arc, this is dq, this is d theta, length is dl, this is radius. What we get now here? This arc length is dl equal to r d theta. So dl we can write r d theta. Here see, dq means lambda dl. I write here. See k lambda dl by r square sin theta. DL means r theta. So means we can write here k lambda, DL means r d theta sin theta by r square. See one r cancel. What we get now here? E net equal to k lambda sin theta d theta by r is there. We can take interval. So what is the interval now? 0 to 180. Here also 0 to 180. Here 0 to 180. So 0 to 180 interval. See k is constant, lambda constant, r constant. We can write outside. So E net equal to k lambda by r, interval 0 to 180 sin theta d theta. sin theta d theta. So integral sin theta d theta means minus cos theta. So E net equal to k lambda by r. So means integral sin theta d theta means minus cos theta. So interval is 0 to 180. 0 to 180. See E net equal to k lambda by r. First we can write upper interval minus cos 180 minus of minus na cos 0, cos 0 we can write na. See first upper limit, later lower limit. Upper limit na minus cos 180 minus of minus cos 0, yes na. See we can write E net equal to k lambda by r. Cos 180 means minus 1, already minus is there 1. Here cos 0 1 minus 1 minus of minus na plus 1. See what we can write, E net equal to 2k lambda by r. What is the net electric field due to this semicircular rod na? See semicircular continuous charge distributing rod na, E net equal to 2k lambda by r. See again once. First what we are doing now, this is the semicircular rod. In this one charge is distributed continuously. We can take first theta angle from base point, initial point theta angle. We can cut small parts. Why we are cutting small parts now? Extended charged objects Coulomb's law is not valid. So we can take, we can cut small elemental regions or elemental charge party, elementary charge charges. So dq elementary charge. So now length is dl, theta is d theta. So this is the radius. Due to this charge, what is the electric field now? De electric field. Why now it is positive? Here outwards is there. That's why De electric field. This makes some angle with theta. Here theta na, here also theta. Make some angle with theta. It has two components is there. One is horizontal components, another one is vertical components. So horizontal component na De cos theta. Why we are writing De cos na? Which say theta is there, that is cos, opposite is sin. That's why it is De cos theta. It is De sin theta. Next, symmetrically opposite. Here we can take dq part. So this dq has electric field De, which makes theta from here. Theta na opposite, vertically opposite. So theta here, which said theta, that is De cos theta. Opposite is De sin theta. This De cos theta get cancelled. Why na? It is a negative side, it is a positive side. So it is automatically cancelled. So we can write here De cos theta will get cancelled due to mirror element, and D sin theta will add. Will add. Why not? Here we can get D sin theta, D sin theta, all parts. This part, this part, this part, this part. This all D sin theta we can add. Yes, na? Then we can get E net equal to integral D sin theta. What interval? 0 to 180. So 0 to 180 De sin theta. Here E net equal to 0 to 180. De means due to this dq. What is the electric field here? Dq na? Due to this dq, electric field is k dq by r square. Length is r, distance is r. This point, what is the electric field na? K dq by r square. Charge is dq, distance is r. So means k dq by r square. See dq means we can write, see before that, linear charge density. Linear charge density means charge per unit length. Charge is what here? Dq. Length is dl. Dq by dl. From that dq equal to what? Lambda dl. So dq equal to lambda dl. Instead of this dq we can write lambda dl. We can write. I write here. See where? Here. Lambda dl. K lambda dl by r square sin theta, like that is there. See here this length is dl. So means arc length. Radius is r. Angle is d theta. From that this arc length na, see length of arc equal to radius into theta. So radius or theta is d theta. Dl equal to r theta. Wherever dl is there, there we can write r d theta. I write here. So instead of dl, r d theta by r square, r cancel, k lambda sin theta d theta by r. K lambda sin theta d theta by r. K lambda by r constant we can write outside. So integral 0 to 180 sin theta d theta. Integral sin theta na minus cos theta. Interval is 0 to 180. We can write first upper limit, later lower limit. Minus of cos 180, minus of minus cos 0. So cos 180 minus 1, minus of minus na plus 1. So minus minus plus cos 0 1. So 1 plus 1 2. 2k lambda by r. E net equal to what? 2k lambda by r. Means due to semicircular rod with continuous charge distribution, what is the electric field na? 2k lambda by r. 2k lambda by r. Okay, na? This is the proof. This one. See, next we discuss quadrant. See quadrant. So this is the quadrant. See this spot. What is that? Here charge is distributed continuously. Is continuous charge distribution. Here this is quadrant. See this quadrant. Here what is the, due to this quadrant, what is the electric field, that only we find out. See here what we can do now. Before what we do like that, see here it is extended object, so Coulomb's law is not valid, so we can cut small parts, small elemental part. See this we can cut small elemental part. This length is dl, charge is dq, and angle is here d theta. From this theta angle, yes na, this is the radius. See here, due to this dq charge, here what is the electric field outwards, so that electric field is de. See here it will be extend na, here theta, here also theta. It has two components, one is de cos theta, here why na, means which side theta, that is de cos theta, opposite is de sin theta. Yes na, here de sin theta, de cos theta. It is along ex, along x axis. It is we can take along y axis. Here see, next this part, this part, this part, like this we can get two components is there. So means ex, all ex added, what we get, integral de cos theta. De means due to this not d charge, what is the electric field? De equal to k dq by r square. So means electric field due to dq charge is de, that is k dq by r square. See lambda we know, lambda means linear charge density, means charge per unit length. What is the total charge? Q, length is L. So we want here this part only. So means lambda equal to charge is dq, length is dl. What we can write? Dq equal to lambda dl, lambda dl. See de equal to we can write k lambda dl. Why? Because instead of dq we can write lambda dl. See one more. See this one, arc. This is dl, this is d theta, radius r. This arc length na dl equal to radius into theta. So means r theta. Where dl is there, there we can write r d theta, we can write it. Yes na. See de equal to k lambda dl means r d theta by here. See or d theta by r square. See r cancel, what we get? K lambda d theta by r we get. So here we can write d means what? K lambda d theta by r. Instead of this d we can write ex, electric field along x axis, that is integral. What is the interval now here? 0 to 90. So 0 to 90 I can write here. See de means k lambda d theta by r cos theta. Yes na, k lambda by r constant. I write here ex equal to k lambda by r integral 0 to 90 cos theta d theta. Cos theta d theta means sin theta. So means e along x axis is k lambda by r cos theta na, sin theta. Interval is 0 to 90, sin 90. So means first we can at upper limit, later lower limit. K lambda by r sin 90 minus sin 0. See sin 0 0, sin 91. So what we get na, electric field along x axis na k lambda by r. This is the electric field along x axis. Y axis na, ey. Ey equal to what? De sin theta. I write here de sin theta. So like that now, all we have de is sin theta. We can add here. See, so we can take integral. So integral de sin theta. De means this is only k lambda d theta by r. Ey equal to de means k lambda d theta by r sin theta. Interval is 0 to 90. How it we get k lambda d theta by r? Actually dE equal to due to this dq, dE this one, dE means k dq by r square, dq means lambda dl, we can write lambda dl, dl means r theta, r d token r cancel, we get k lambda d theta by r. Here I write k lambda d theta by r sin theta. K lambda by r is constant, so we can write outside. See here, we can write outside. So Ey equal to k lambda by L, or we can write outside. So what we can write? Integral sin theta d theta. Sin theta means k lambda by r, sin theta na minus cos theta, we get interval is 0 to 90, 0 to 90. So k lambda by r, see cos 90 minus cos 90, 0 minus of minus plus cos 0. See cos 90 0, we can write k lambda by r, cos 0 1. So we can get k lambda by r. It is along y axis. Along y axis net electric field is k lambda by r, along x axis k lambda by r. So both na net. So this is k lambda by r, this is k lambda by r. So net means this is the net electric field. So net electric field is vector quantity. We can use vector law of addition. What is the angle here? 90 degrees. So we can write, see here, net electric field Ex plus Ey equal to root of, see k lambda by r na, we can take E, so means you can write here k lambda by r whole square plus k lambda by r whole square. So what we can write? K lambda by r outside, so Ex plus Ey equal to k lambda by r outside. Here only we have root of 1 plus 1, means net electric field. Net means Ex plus Ey, that is k lambda by r root 2, means due to quadrant charge, continuous charge distributing rod, what is the net electric field na? See E net equal to root 2 k lambda by r. This is the net electric field due to this continuous charge distributing rod which is in quadrant shape. Before semicircular shape 2k lambda by r, quadrant shape root 2 k lambda by r. This is the electric field due to quadrant. Electric field due to quadrant. Now we can see general case is there. All we can use by using this one only. See once what is the general case now. Here, see, first we can take here, see, like this. See this making some angle here. See this angle is alpha. Alpha. We can draw a line in middle. See this is alpha by 2. This part also alpha by 2. Yes na? See here in this one, this side we can take from here theta angle. This is a theta angle. We can cut a small part. This is a dq, length is dl. Here now what is the electric field now? Here de. It has two components. One is, see here theta, here theta now, see this also theta. Here see it is d cos theta, it is d sin theta. See, understood at this point? See actually semicircular, it will be total angle at point P. What is na? Alpha. It is line on middle, we can write line. See this alpha by 2, this alpha by 2. From this side here theta angle we can cut small elemental charge, elemental charge, that is dq, length is dl. Due to this charge de electric field is there. See here it is theta, so this na theta angle. So this angle equal to this theta. Which side theta is? That is de cos theta. Opposite is de side. Exactly symmetrical. Here we can take now this part. See this is, it is what now? Here this is dq charge, dl length, d theta. This also same here. See electric field. See this is theta now. From here we can take now this is theta. So means automatically this also theta. This what we can write here de cos theta. This is de sin theta. This part get cancelled. What we have? De cos theta is the. See we can write here all this part we can cut now. All we can take that we can take integral. Integral E net equal to integral dE cos theta. dE cos theta. So first we can write dE. So dE means electric field due to this charge. What now here? K charge is dq by distance is r only. So means r square. What is the electric field now? dE equal to k dq by r square. dq means we can take lambda. Lambda equal to what? Linear charge density. Charge per unit length. Charge is dq, unit length is dl. So from that what we can write? dq equal to lambda dl. So means instead of here we can write k dq by r square cos theta integral. What is the interval now? This side minus alpha by 2, this side plus alpha by 2, means minus alpha by 2 to alpha by 2. See here minus alpha by 2 to alpha by 2, k dq by r square. So cos theta. See dq means lambda dl. I write here lambda dl. Interval is minus alpha by 2 to alpha by 2 cos theta. See dl. We want dl now. See dl means what now? Here why we are finding dl means here theta is there. K is constant, lambda constant, dl is constant. So dl change now. So theta varies. So that's why we can write in terms of theta. We can write. See here dl now. This one, this length now. This is d theta. Radius is r. This dl equal to what now? Radius into theta. So means r d theta we can write. Instead of dl we can write r d theta. See what now? Integral k lambda dl means r d theta cos theta by r square. 1 r cancel. What we get now? K lambda by r and equal to integral k lambda by r cos theta d theta. Cos theta d theta. See here in this one k lambda by r is constant. Integral cos theta d theta. What is the interval now? Minus alpha by 2 plus alpha by 2. See minus alpha by 2 plus alpha by 2. K lambda by r. Cos theta means sin theta. Interval is minus alpha by 2 plus alpha by 2. See here k lambda by 2 we can write first upper limit sin alpha by 2 minus of sin minus alpha by 2 sin of minus theta na minus sin theta. What we get na here? Minus minus plus we get. See what we get na? See E net equal to k lambda by r, k lambda by 2, k lambda by r only, k lambda by r sin alpha by 2. Here minus of minus na plus will get. So 2 sin alpha by 2, 2 sin alpha by 2. What we can write? E net equal to 2k lambda by r sin alpha by 2. This is the general case. For before we can get semicircular, quadrant, we can find out by using this formula. See first what we can do? Semicircular at P point, what is the electric field? We find out. For that what we can do? This total angle is alpha. It is divided into two parts, alpha by 2, alpha by 2. From this side we are measuring the angle, theta angle. We can take dq charge and length is dl d theta r. Due to this charge is the electric field is dE. It has theta. This one means this theta. This side is which side theta? That is cos theta. Opposite sin theta. DE is cos theta. DE is sin theta. We can cut symmetrically. Here DQ na. This one symmetrically we can cut. See this DQ. Here theta. This one DE is cos theta. DE sin theta. This DE sin theta. DE sin theta get cancelled. We get DE cos theta. This all DE cos theta added now. We get net DE cos theta. See this part minus alpha by 2, this part plus alpha by 2, minus alpha by 2, 2 plus alpha by 2 interval dE cos theta means total rod covered. See k dq by r square. What now? Electric field dE means k dq by r square. So interval is minus alpha by 2 plus alpha by 2. dq means I write here lambda dl. I write here lambda dl cos theta by r square minus alpha by 2 plus alpha by 2. So interval k lambda dl means r d theta. Why na? Arc radius into d theta. So that we can write r d theta cos theta, r cancel, k lambda by r cos theta d theta. K lambda by r cos theta d theta. K lambda by r is constant. We can write outside interval integral cos theta d theta minus alpha by 2 plus alpha by 2. Cos theta means sin theta. Integral of cos theta sin theta. Interval is minus alpha by 2 plus alpha by 2. First upper limit, next lower limit. Sin of minus theta minus sin theta. Already minus is there, plus we get. So means plus 2 sin alpha by 2. K lambda by r 2 k lambda by r sin alpha by 2. For example, see first case, if theta is 180, when we can get 180? Semicircular rod. Yes, na? This case, theta we can write 180 na here. E net equal to 2k lambda by r sin alpha means 180 by 2 means 90. Sin 90 1. So what is the net na? Electric field 2k lambda by r. So means net electric field due to semicircular rod, continuously charged distributing rod is 2k lambda by r. We can take, for example, theta equal to 90. 90 means quadrant. What we get? E net equal to 2k lambda by r sin, here na sin alpha by 2. Alpha is means alpha is what here? 90. So 90 means, so this we can take, theta means here alpha we can take, here also alpha, here also, that means alpha. So alpha 90 means sin 90 by 2. Sin 90 by 2 means 45. Sin 45 means 1 by root 2. I write here E net equal to 2k lambda by r sin 45 means 1 by root 2. See, root 2 cancel means root 2. What we get to root 2k lambda by r. This is the net electric field due to quadrant. So E net equal to what? Root 2k lambda by r. So this is the general case. What is the general case na? E net equal to 2k lambda by r sin alpha by 2. By using this one, we can find easily what is the net electric field due to semicircular rod, quadrant rod. We can find out. This is the general formula for finding electric field due to semicircular or quadrant. What is the formula? E net equal to k 2k lambda by r sin alpha by 2. This is shortcut for finding what is the net electric field due to semicircular rod, means this one, continuously charge distributing semicircular rod, or quadrant na this one. So this quadrant, for this what is the net electric field? What is the formula? E net equal to 2k lambda by r sin alpha by 2. Thank you.